Hello. So we'll have some other problems based on the same equation by parts or the integration by parts. So we'll now solve, let's see, this problem is integration of e raised to x into sin x. I am purposefully taking this problem. It is slightly difficult problem. Not very difficult, but it is still not that easy. But let's see how to solve this. So we'll just see, the first thing I'll do is I'll call I is equal to this, and this is equation 1. I is equal to, using LIATE, trigonometric will come first and e raised to x will come later. So we'll have sin x into integration of e raised to x dx minus integration of integration e raised to x dx multiplied by derivative of sin x into dx. This is equal to e raised to x into sin x minus integration of e raised to x into derivative of sin x is cos x dx. This is equal to e raised to x sin x as it is minus, again cos x is trigonometric, e raised to x is exponential, we'll use by parts again. Same logic. So I will now write in bracket, because this minus sign, once I expand this, in every by parts problem there will be two different integrals. And this minus sign is common for both. So I am writing this in a bracket. This is very important to be followed as a practice, because otherwise, despite of getting the right answer, the minus sign, if it is not applied everywhere, then the third term will have different signs, either plus or minus. So to be careful with that, I am maintaining the consistency. Minus sign is as it is, and I am putting everything else in bracket. So I write cos x integration of e raised to x minus integration. I am purposefully avoiding to writing dx here in many cases, because I don't want this to be written far too long. So just to shrink it a bit, make it smaller, I am avoiding that. When you solve this in the examination, if it comes, write dx everywhere in every integration. Cos x into integration of e raised to x minus integration of integration e raised to x into derivative of cos x into dx, and this bracket is completed here. So I will now reach e raised to x sin x minus in bracket e raised to x integration is e raised to x into cos x. So this comes out to be e raised to x into cos x. Integration of e raised to x will be e raised to x. So this is integration of this integration e raised to x will be only e raised to x into derivative of cos x is sin x, but it is not sin x, it is minus sin x. So please be careful about this. Derivative of cos x is minus sin x, so there will be minus sign here, but there is a minus sign here as well. So minus into this minus will be plus, but there is a minus sign of this entire bracket. So minus into this is already absorbed minus sign here. Minus of minus will become plus, and then in the bracket there will be minus cos x, so it is effectively minus. Now are we going to solve this again using by parts? No. This e raised to x into sin x dx is I. So this is effectively minus I. So this is minus I ये सारा के plus I हो जाएगा. So I plus I 2I is equal to e raised to x sin x minus e raised to x cos x. This is not required because I replace this with I. I would have written minus I here and only I here. This minus I will come here, I plus I will become 2I. And then I can divide by 2 and I get this answer plus C. I is equal to. I hope you get this. What are we doing is we are putting trigonometric equations first and e raised to x as exponential as later. So sin x into e raised to x integration minus integration e raised to x into derivative of sin x dx. Sin x into e raised to x sin x minus integration of e raised to x derivative of sin x cos x dx. So I'll solve this now. So e raised to x sin x minus this minus. Now using LIT cos x e raised to x integration minus integration of integration e raised to x into derivative of cos x dx, and this is bracket completes. E raised to x sin x minus cos x e raised to x cos x minus minus plus, this is e raised to x, derivative of cos x will be minus sin x, so I'll write minus minus plus and then minus will be minus e raised to x sin x integration, but integration of e raised to x into sin x dx is I, so this is minus I, so this minus I will come here and will be I plus I is 2I, so 2I is equal to e raised to x sin x minus e raised to x cos x. So I is equal to e raised to x sin x by 2 minus e raised to x cos x by 2. If you want, you can take e raised to x upon 2 common. So e raised to x the whole upon 2 in bracket sin x minus cos x plus c. I hope this is okay. We'll solve one more problem of similar kind. Let's solve a simpler problem, but based on trigonometric functions. Integration of x sec square x into dx. Now this sec square x, we don't have to worry about this because integration of sec square x is allowed. So I'll just adjust I is equal to x integration of sec square x into dx minus integration sec square x into dx multiplied by derivative of x into dx. This is equal to x integration of sec square x is tan x minus integration of sec square x is tan x into this is 1 into dx. X tan x minus log of sec x plus c. Integration of tan x into what is integration of tan x? Integration of tan x is log of sec x plus c. If you have any confusion with this, you can try multiplying integration of tan x is equal to integration of tan x into sec x divided by sec x. So I multiply and divide, it will be integration of tan x anyway. But if I put this as t, the derivative of sec x is sec x into tan x. So this is dt. dt upon t is log t plus c. So you can get this very easily. I'll now type out the notes and I'll send you some of the, not notes, but the questions that I would like you to attempt. I think the questions will reach you by tomorrow morning and this video will reach you by late in the night. I hope you're doing good. I hope this is fine. And I hope this works good. Thank you.